Good evening, everyone, and welcome back to another lecture in cloud computing. From today onwards, we are going to start our discussion in the subtopic of how to perform or how to carry out automation in Amazon Web Services platform, right? And in this subtopic, there are two specific services that helps us to kind of perform automation when it comes to cloud computing platforms on AWS, right? So the first service is known as AWS CloudFormation. Sometimes you also see that is being referred to as infrastructure as a code. So everything that we have done till now kind of takes care of when it comes to a full stack deployment of organization's network or an ecosystem on AWS, right? So if you want to do that manually, then you would have to visit all of these individual services one by one, and then you would have to set it up, right? So essentially, if you kind of boil this down to having to deploy all of the different services that we discussed up until this point of time, then you would be typically dealing with four-ish services, give or take. Those are the major four services that we will be dealing with, right? So for example, if you want to set up your own architecture of what your ecosystem is going to look like, then you will be mostly dealing with the virtual private cloud, right? And you will be setting up your different subnets, your network conditions, basically. That is essentially what it helps us achieve, that how to set up public subnets, how to set up private subnets, how to take care of the IP assignments using the CIDR blocks, those kind of things, setting up elastic IP addresses, endpoints, VPN connections, and those kind of essential features are essentially covered by VPC, right? And after that, if you go into the deployment of infrastructure as a service, right? If you want to take care of infrastructure as a service on AWS, then essentially once the VPC is set up, you would move on to the service for EC2, right? Which will allow you to kind of generate different type of compute engines, depending on the instance portfolio that you're creating, right? What's the instance type, and then the associated storage, memory, processing power that comes with it, and then the authentication measures and stuff like that, how to do all of those things, right? So that is taken care of by EC2, right? But you have to do that manually. So within EC2, we know for a fact that instead of manually kind of instantiating different EC2 instances, the way to kind of take care of that in an automated way from the EC2 portal itself or the EC2 dashboard is to go for auto scaling groups, right? Which doesn't just take care of the provisioning of EC2 instances, but it also kind of accommodates the aspect of auto scaling and elasticity within ASG as well, right? So ASG thereafter allows us to take care of elastic load balances with the help of what we call as target groups, essentially. So it will be tracking a certain parameter, and based on that, the ELB will be carrying out its responsibility to make sure that depending on the type of load balancer that you're using, for example, if you have an application load balancer, then it will try to optimize the requests that is coming from the clients across all your backend servers that are being executed and monitored by the auto scaling group, right? So that takes care of all your instance deployment. And after that, it is a matter of storage, right? So storage, there are three different forms, right? So one comes attached when you are launching your EC2 instance, which is the traditional volumes that can be associated with the EC2 instances. So that is in the form of the elastic block store, right? And then we also learned about the elastic file system. And then on top of that, we also learned about the S3 buckets, which is like a universal location of anything that does not fit into the criteria of elastic block store or elastic file systems. Then you can store whatever that you want, whatever data type that you want within an S3 bucket, which is available across your entire region, right? So architecturally speaking, there is a distinction between how S3 behaves versus how EFS may behave versus how elastic block store may behave. And then finally, after storage, you need to have some capabilities with respect to storing and efficiently managing your data, querying your data and stuff like that. So for that, you need some sort of database service. So we discussed about the relational database service, and we also discussed about the non-relational database service, but there aren't many different forms of non-relational database services on AWS. It offers the key value non-relational schema, which is essentially offered by the service of DynamoDB. So essentially, that is why we're just writing DynamoDB instead of specifying it as a non-relational services, but we will just give it a tag of NoSQL in order to just kind of outline the fact that DynamoDB is a part of the non-SQL, the NoSQL category, essentially, right? So together with these 4 different features, and these have different sub-services and stuff like that. And of course, we are not talking about IAM and all those things, because you need to set that up prior to working, either prior or just after you set up your VPC, as long as you have an understanding of what your organization's hierarchy is going to look like when it comes to access control and authentication and all those stuff, right? But if you still want to kind of recap, what IAM allows us is to first and foremost create user groups, and then to those user groups you can add add different user policies or individual users, and then you can essentially associate with them different types of permissions or permission policies that will essentially take care of your authentication business within your ecosystem that you tend or intend to launch within your EC2 platform, right? And then in addition to that, you also have the capability of creating roles, IAM roles, which basically allows your different not EC2, keep saying that, AWS resources to kind of assume those roles, and then associated to those roles, there are certain permissions, right? And essentially that allows your different AWS resources, whatever those resources may be, right? It could be an EC2 instance, it could be an S3 bucket, it could be a RDS database and stuff like that, but depends on the role and all different permissions that comes with it. You can create different roles, and then you can assign different AWS resources to those roles, such that those AWS resources can essentially act on behalf of you to kind of invoke or execute certain operations that those permissions allow them to do so, right? So other than that, IAM also allows us to create authentication keys. So you can create different access keys, which basically is interpreted as API keys when we kind of want to embed the invocation of certain resources on the cloud within, let's say, a program that we are writing, right? So we want to kind of attach it. Then we need some form of way to authenticate or allow our programs that we are writing to these AWS resources, right? And then that is essentially done with the help of access keys. And then we also can generate different authentication keys that from the terminal itself or from the interface itself allows us to kind of interact with these different resources, right? So that is kind of like the ecosystem of setting up infrastructure as a service with varying degrees of sub-services, which kind of forms the fundamental or foundation of a complete stack on the cloud platform, right? Anything after this point is kind of to make things more optimized, right? So when you think of automation, it does not necessarily bring anything new to the scenario with respect to the resources as such, right? It's not like CloudFormation is going to introduce a new type of resource altogether. It's just going to do all of these things that we have discussed already, but in a more efficient way, right? So it's not like you have to visit all of these different services through the AWS console and then set this up individually and connect them together. So how can we better it, right? So how can we improve this process of infrastructure provisioning? That's what CloudFormation is all about. Similarly, when we go forward and when we talk about things like the elastic beanstalk, right? So this is a more efficient way to develop web applications, okay? Using all the different technological stacks that we are aware of, right? So for example, if you want to do the LAMP stack, which is a PHP-based development, you can use that, right? And then if you want to use the MERN stack, which kind of uses JavaScript development, then you can essentially use that as well within the Elastic Beanstalk, right? So anything from this point onwards is less about learning new resources altogether and more about how can we take everything fundamental that we learned prior to this point, and how can we further improve the process of interacting with them, right? So that is basically what automation is all about. And that is what we are going to take a glimpse into, is how these resources can actually improve the process further, right? So diving into AWS CloudFormation, in short, it is also known as IAC service, right? Or infrastructure as a code, right? Or not as a code, but infrastructure as code. So what you do essentially is as a script, and the script is of two different types. It can either be JSON format, or it can either be another script type, which is known as YAML, okay? Which is, they claim it is not a markup language, that it ain't a markup language. So it has a very funny expansion of its acronym, but it's a script language at the end of the day, right? So you can either choose to use either of those two languages, whichever you are familiar with. If you have not worked with YAML before, rest easy. It's not that difficult. As long as you understand the inherent structure of how YAML is written, then you can pick it up very fast. It's like learning a new markup language. So at the beginning, you would need some reference to understand how to express different components. But once you start working with it, it becomes pretty easier, right? So initially, in the few use cases that we will discuss, I will talk to you about the structure of the script language in both YAML as well as JSON. But in the exercises that we will perform, at least within the domain of CloudFormation, we will be using YAML, okay? So it's always better to kind of learn something new and then put that within your skill set, so to speak, okay? So essentially what you do is you take that script that you write, within which you specify all of your different provisioning features that you want, right? So it could be with respect to, let's say, as simple as launching a EC2 instance in a particular subnet of a VPC within a given region. Or it could be a complex full stack scenario, which includes, let's say, a web server, which includes a load balancer. It includes a mapping of which subnets will have which type of guest OS distribution when you are kind of provisioning different EC2 instances, and all those different complications. You can kind of include that within your script, right? So what I'm trying to say here is that if, let's say, your architecture has some sort of a deployment requirement that when you're testing it, let's say, this is just for hypothetical example, that when you're testing your environment, you want to use some sort of a Linux server, okay? But during your production environment, you want to change the distribution of Linux. So here, maybe you're using the Amazon machine image for your Linux distribution. And once you move here, just for example, say you want to switch to Red Hat, okay? Or you want to switch to SUSE Linux or something like that. Or in a different subnet. So let's say if this is happening in subnet A, you might decide that, okay, in subnet B, I would like to use, for my production environment, I would like to use a Windows 2022 server, something like this, right? So all of these different variations with respect to how you are going to deploy it, if you did this manually, right, this would have been a little bit difficult. If you try to appreciate the advantages of CloudFormation, think about just for this much. Okay, let us just ignore the fact that we don't want an elastic load balancer, that we are not launching or transforming any of these production environment instances into a web server, which has database support and all those stuff. Let us just ignore that and let's just focus on the fact that this is the deployment requirement that we are dealing with, right? That in subnet A, testing in production will have different OS distributions for our EC2 instances. And then another subnet will have a different instance of Windows Server and stuff like that, right? If you did this manually, what would it take us to kind of achieve this scenario? Well, this will be a problematic scenario because, first of all, during the testing environment, there is no specification in subnet B as to what kind of guest distribution that we will be dealing with, right? So you're kind of free to kind of choose whatever you want. So let us just complete this scenario and let us just say that in testing environment, let's say we want Windows 2060 for whatever reason, right? We are not thinking about practical rationality as to why it is specified as such, but let us say this is the difference, right? So as long as it remains in the testing environment, we have to manually go to EC2, right? Maybe using ASG, you can kind of automate some of these processes, wherein you can specify that, okay, the ASG that I'm going to run is going to be in subnet, let's say 2A, if it's in the second region, then I'm going to be deploying all my EC2 instances with this particular Linux instance. And then for subnet B, I can launch another ASG instance, which will, let's say, consist of 2 to 3 different EC2 instances, which all will be running Windows 2060. Note here, if you still launch ASG, right? ASGs can launch homogeneous instances. ASGs cannot take for every instance a new type of portfolio and then kind of create those instances one by one, right? It is not capable of doing that. It can span across multiple subnets, right? But it requires a unique, not unique, but a universally same portfolio for all the instances that it would be monitoring, which could be spread across different subnets, right? So essentially what you need to do is either manually set these things up. And then once your testing environment is done, then you need to kill all of these different instances. And then when you switch to production environment, then you need to redo the process of infrastructure provisioning. And then you need to individually specify the change in the guest OS distribution that is now required for all your different instances that will go live during production, right? So you should be able to appreciate at this point that if you kind of scale this up, right? If you're just looking at a single instance or 2 or 3 instances, this is still digestible. We can still kind of live with the fact that we need to do this process manually, right? But if you move forward and you kind of scale this tens or 100 more times, then it kind of becomes a tedious task to having to carry this out manually, keep a track of when testing switches to production, blah, 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 how to map different guest OS distributions to different instances, depending on the subnet, depending on the region, right? We can introduce more complications to this particular discussion by saying that, okay, now if I change it from region A to region B, then I will have another different set of machine image mapping for different types of cases, right? And that kind of further complicates the whole scenario, right? So all of this can be specified as a script if we are using AWS CloudFormation, right? So all we need to do is the way we wrote it here. That is exactly, well, using the script syntaxes, that is exactly how you need to specify as well all of these differences, right? So that is what or how IAC helps us. And it is a very powerful tool when it comes to performing automation. And the way you execute your IAC scripts is basically using the service called AWS CloudFormation. Now, you can write your scripts offline and then upload them to an S3 bucket. And then when you go to AWS CloudFormation, you can simply say that I already have my script ready, and you can upload it from S3. It's the same as developing a schema for, let's say, your relational databases when you're working with the RDS service, that instead of specifying the schema, you can simply say, I already have some data, I already have the schema ready, it's stored in an S3 bucket. So let's create that database from S3. The same goes for here, that anything that can, or that wherein you can provide something which can be done offline can essentially be done by uploading that file essentially to Amazon S3. And then when you're creating something, you upload it from S3, right? So S3 is like the go-to place of all your most storage. And then Amazon CloudFormation will kind of go through the different directives that you specify in your script, and it will create your output, right? So anytime you want to execute a certain service, okay, which is basically infrastructure as a code, then that is, if you write infrastructure as a code script, this is executed using AWS CloudFormation, okay? And I will tell you where we are going with this. So this will start all your resources, or this will provision all your resources. Now, another thing that you need to know is, okay, I have created all of these different EC2 instances, or I have created fully functional program stacks. How do I deprovision them, right? Do I individually go to each of these different individual portals or individual dashboard, and do I kill the services from there? No, you do not do that. So whenever you want to deprovision something, you basically kill your stack, kill the stack from CloudFormation itself. Okay, so here anything that we deploy using infrastructure as code, okay, we call that as a stack. Now, the stack can be as simple as, let's say, one single EC2 instance in any given subnet of a region, or it could be a completely complicated, fully functional, let's say, software stack which supports a web application or something like that, that has database access, load balances, and all those different kind of features, right? So whatever it is, when you work within the environment of CloudFormation, whatever is being provisioned, we call that as a stack. And the stack can have whatever it is that you specify in your script, right? But there is one niche detail that you have to keep in mind when it comes to deprovisioning, is that any resource that has not been provisioned by CloudFormation, CloudFormation will not be able to deprovision that either. Okay, so what I mean by that is, let's say you write all of these scripts and stuff like that. Let's say, and on top of this, you create some S3 buckets in order to support storage for this hypothetical discussion that we were having. And then this S3 bucket was, let's say, provisioned by a script directive which was present when you executed your CloudFormation stack, right, for this particular purpose. And prior to deprovisioning it, within this S3 bucket, you added some data. All right. So notice here that this data that you add after your stack has been provisioned by CloudFormation is not a part of the CloudFormation script. Okay, you cannot essentially, if you did not specify whatever operations within the script will not be able to roll back all those operations. So essentially, the deprovisioning is essentially a rollback operation where it kind of kills all of these different infrastructure or resources that it kind of provisioned, right? So anything that is not a part of the script needs to be deprovisioned by you, right? So this is the only note that you would like to make when it comes to dealing with this particular service, is that anything that is not a part of the IAC script, or which is not a part of the stack, the original stack that CloudFormation provisions, CloudFormation will not be able to deprovision those services either, right? Okay, so just keep that in mind. All right, so there are many different use cases. Again, you can check it out on the documentation for AWS CloudFormation. Again, it's a good read, just like any other services. And there are also some customers, well-known customers, that are already using CloudFormation, right? So you can check those out in your own time, and you can give it a read to kind of improve your understanding of how these companies, these organizations are using CloudFormation in their use case scenario, and how you can do that as well for your organization if you would like to, okay? So with respect to the cost model, please keep in mind that utilizing CloudFormation is absolutely free. You can create as many stacks as you want. Where it charges you is basically depending on the resources that you are going to deploy, right? So for example, again, if you deploy an RDS service, or if you deploy an EC2 instance, then your pricing model will be based on the resources that you are provisioning using CloudFormation, and there's no charge when it comes to just working with CloudFormation, okay? So that is something that you have to remember. In terms of code templates, again, as we discussed, you can either use JSON format, or you can use YAML format. So I will walk you through both of those different formats. What is the difference between that? But for the exercises, we will try to work with YAML format, work with something new, hoping that most of you haven't worked with YAML before. But I'm hoping that if you're not comfortable with YAML, at least you have some familiarity with JSON in order to understand what we are trying to do here, okay? And you can use either of these formats. There is no specific benefits of, let's say, using YAML over JSON or vice versa, right? So whatever you're comfortable with, just stick to that. That's all that matters, all right? So let's first discuss about this YAML doc before we move forward. And it's pretty clean, so to speak, right? So there is a lot less clutter if you want to compare it against JSON. But again, that is a subjective matter, as some people would beg to differ that JSON is more structured, and having that clutter helps it to keep it more structured and systematic. But hey, to each their own, right? So when you start a YAML documentation, okay, whenever your script starts, you basically have these 3 dashes in order to indicate the fact that this is the starting point of your YAML documentation, okay? Any of these values that you see here, it is treated as a key value pair at the end of the day, after all, right? So if you have something like this, where it says Ray and then it provides a string, which is written within double quotes, or it can also be written using single quotes as well. So this is a key value pair mapping that is taking place here. And this is pretty straightforward. There's nothing much to explain when it comes to key value pair mappings, right? And you don't have to declare any kind of data types, depending on the value that you write, just like, things like Python or JavaScript works. Whatever value that you write, it will understand the data type of that value, and then it will associate that to the key that you are specifying it with, right? So you don't have to declare. But in contrast to that, if you think in terms of JSON, then JSON requires everything to be in string format, right? So that is basically one difference when it comes to YAML and JSON as such, that every data type is going to be a string. But however, in YAML, you can specify whatever data type you want. So here you can see that the first two data type mappings for the key value pairs are basically a string. Then you have a floating point value, then you have a Boolean value, right? And then you can create arrays and stuff like that. You can create dictionaries, you can create nested arrays and all these kind of things, right? So essentially, when you try to create an array, right, and when you're trying to create independent elements that belongs to the same key, you use a single dash, and then you essentially specify all those different values that will be associated to this particular key. So here in this key called calling birds, this is just the name of the key, but it does not have an individual variable or an individual data value. It has an array that is associated to it. So essentially, the other new thing that you have to kind of keep a track of, or you can make a note of the fact that in YAML, if you want to create an array, you use a single dash, and in every new line, you specify each index of your array, right? So that is basically how you set up an array-like environment. And then in addition to that, there is also a dictionary that you can create, a nested dictionary. So here, what you can do is you can further create a nested array here. So if I here entered the new line and then went an indentation to the right and then created 4 more elements, then that would have been a nested array for any of these individual blocks, right? So, and then you have a dictionary. So dictionary is basically, you can think of a nested YAML structure itself. So here you have the key, but then each of these values is a key value pair itself. So that is what we refer to as a dictionary within the YAML structure, is basically when you have for a given key of the original root, you basically have the values as key value pairs themselves, right? So in object notation, if you want to think about it, then this can be treated as a nested object, right? So essentially you start off with an object itself, then it has a key, and that key itself is another object within that. The value itself is another object, right? So you can kind of create further scenarios here, right? And then this one is like a nested dictionary that you see here, the packages one, because you essentially have another set of key value pair mapping as the value of a key, which is already a value of the root key, right? Or the parent key, right? So there is a little bit of confusion, but let's try to keep it as clear as possible, right? So a few things, if we summarize this whole structure, when the YAML document starts, it starts with 3 different dashes. Each item is expressed as a key value pair. Data type can be anything, okay? You don't have to stick to something like a string as you do in JSON format. If you specify a string, you can write it as double quotes. You can write it as single quotes. I think there is an opportunity for you to also write it without quotes, the string value as well, and leave it to your YAML to figure it out that it's a string data type. But just for the sake of sanity, I would advise or suggest that whenever you're working with a string, at least, follow the notations of string, use the double quotes to kind of make sure that everybody keeps their sanity and they don't forget the fact that it's a string value, okay? Any data types can be given. We talked about that. If you want to create an array, then you specify your keys, and then using a single dash in every new line, you specify the individual indexes of your array that you're trying to create here. If you're trying to create a dictionary, it's kind of like a nested object, okay? So what that means is that you set up your initial key, and then instead of having a value, you set up your individual key value pair mapping after doing a small indentation, but without any other characters like you have seen in the array notation itself, right? And then you can nest your arrays, you can nest your dictionaries, and you can repeat that process in order to create as complicated of a YAML structure that you want, right? So it's pretty straightforward, right? There is even with this much of information, it is easy to kind of digest what we're dealing with, right? This is a basic structure. Now, if you kind of go with this conversion of this YAML script to JSON script, well, what are the differences? Well, the first differences, or the main difference in terms of the structure, is as YAML starts with 3 dashes at the very top, JSON is basically enclosed within an opening and closing curly braces. So everything that you want to write within the JSON script needs to be kind of incorporated within these opening and closing curly braces, right? So that is the first main difference. The second main difference is you cannot have any different types of data, right? You cannot have different data types in JSON. In JSON, everything needs to be specified as a string. So that goes for both your keys as well as the values that you're working with, right? So everything except for numerical values, you need to specify that in string format, right? The main thing that is different from basic object notation in JavaScript, not JSON, but I'm just talking about how to write objects in JavaScript. If you have worked with JavaScript, you will kind of understand what I'm talking about. If not, don't worry about it. The main thing that I'm trying to specify is that if you're working in regular JavaScript and you're creating an object, you will see a structure that is very similar to JSON, right? But the only difference is that the key is written similar to what you saw here in the YAML script and not as a string. But when you typecast this to JSON, okay, when you take a normal JavaScript file and you convert that to .json instead of .js, right? You basically call a method called stringify, and what it essentially does is that it transforms all of these different keys to string values as well, right? So notice here the only thing that is remaining not as a string, but you may choose to convert that depending on how you consume this numerical values, is essentially your numerical values. The other main difference is you don't have these indentation and these single dashes. It's a language which seems very similar to how Python works, right? It's heavily indentation dependent, but except for the fact that it has these simple characters to kind of represent what is going on. But if you work with an array in JSON, then you will have to use the traditional array constructs, which is basically the third brackets, and then one after the other, you specify the different items, okay, preferably in a new line to kind of maintain the structure of the array that you're working with. Similarly, if you're working with a dictionary, and again, dictionary at the end of the day is basically a nested object notation, okay? So that means if you start a nested object again, basically you need to enclose everything within curly braces, just like you did at the very beginning for your entire script itself, right? And everything else will kind of remain the same. So these are the two main, not the main, these are the basic structural differences when it comes to either working with YAML or when it comes to working with JSON, right? So you have to remember these main differences and select a script, work with it, and kind of keep on getting better and better at it, right? But regardless of what script you use, you still should be comfortable enough to see a YAML script and be able to translate that to a JSON script and vice versa, right? Because not all the time you will be working with YAML or JSON, right? You yourself can choose a particular script and stick to it, right? But if you're dealing with somebody else and they prefer a different type of script, which you don't, like you're using JSON and they're using YAML, and they provide you with the structure, then essentially you should be able to kind of reason with what they have developed, okay? So this is a YAML template when it comes to developing a CloudFormation and invoking or provisioning a stack within CloudFormation. Again, remember, we are not going to individually identify different resources when it comes to working with CloudFormation. We will call it as a stack. The stack can have anything within that, right? When it comes to what type of resources are being provisioned, right? So this example here is a very simple example, okay? And looking at it, you should be able to kind of intuitively tell what it is trying to do, right? So for those who are still reading through this, it is basically launching an AWS instance, all right? Specifying what machine image that it wants to use, specifying the portfolio of the instance type that it wants to provision, specifying what key name or what key it should use in order to perform authentications later on if somebody tries to SSH into that terminal, of the EC2 instance that will be launched. And then finally, it specifies the elastic block store volume, the type of volume that it will be using. It's an input-output optimized volume, so it specifies the IOPS values as well. It's not a general purpose SSD. And then remember that every time when you terminate an instance, okay, it asks you that your block storage, which is associated to your instance, will also be deleted. Do you want to go ahead with that or not, right? So this is what the delete on termination is essentially doing, that what it is saying that once this instance is killed, do not destroy the volume, the storage volume that was associated with it, so that you don't lose the data, right? And then you specify 20 gig size of your volume, right? So now, if you think in terms of YAML, right? So essentially, we just need to write it one by one, as we saw here in this simpler example, which is like a non-AWS YAML script example. So all we do is that the root directories have like all of these different mappings, one after the other in the same indentation level, right? If you want to specify a child resource of a given key, you just go one indentation to your right. I would suggest try not to use tab. There is a big debate of how indentation should be done with respect to either using white spaces or whether it should be with respect to using tabs and stuff like that. I know for a fact in Visual Studio Code, you can set up the tab behavior to work as a white space. If you go to its settings and change that, I don't believe other editors might have the same features. But a suggestion here would be to kind of stick to white spaces, because this thing can grow pretty fast. Okay, and if you're using tabs, then you might end up on particularly this side of your screen, the right side of your screen, even if you're working with a very large screen, right? So it is a suggestion that when you're working with these scripts, when you are setting up the indentations, try to stick with white spaces in order to create those indentations. Okay, so it will be easier to manage looking at a very large script. All right, so it specifies what is the template. Each of these things are called a template. The CloudFormation IAC codes that you write is treated as a template. So you need to specify what is your template's formatting version, because the formatting can change. So this is a template from 2010 established. It does not update that often, but when it does, you need to be aware of what changes needs to be made. Gives a description. This is completely optional. Okay. Description is not something that will be provisioned. So this is more of a documentation kind of thing that is provided for your script, rather than an actual resource execution. What is the most important key in this particular script, whether you write it as a YAML or whether you write it as a JSON, the main thing that you guys need to be focused on is this resources key mapping. All right, because this part, anything that you specify within this key, okay, is what CloudFormation will provision as resources on the environment, right? So this is where the importance lies. So this just specifies that there is going to be an EC2 instance. This is just the key. The value, it is what is more important, right? So the type, you specify that is going to be an EC2 instance. Then you specify its properties, the image ID, instance type, key name, and block, and all of these different things, right? So it just carries on from there, right? Another thing to note is that you can also upload your scripts to S3 bucket or directly to the CloudFormation portal using TXT formats. But I would advise against that. Just stick to either JSON or YAML. It's a more popular choice and a more structural way of working with your templates. All right. So if you want to take the same thing, the same YAML script, and you want to do a translation to JSON, you can see that we have a starting brackets here. We are missing the 3 dashes here, essentially. But essentially, if you write it in YAML format, it will kind of understand this, but you need more stricter environments for working with JSON here. All the keys, you can see that it is being treated as a string value, okay? And anytime that you see there is a numerical value on the value side of your key value pair mapping, that is left as numerical, but everything else, other than the Boolean and numerical values, they need to be specified as a string value itself, right? And whenever you create an array, you essentially specify the third brackets to kind of enclose the environment. And then if you are creating an array within the YAML environment, you just go to a new line, indent it to the right, and then use a single dash to specify the beginning of the first index of your array itself, right? And then it can have further child nodes and stuff like that, depending on the type of scripts that you're writing, okay? So Again, to break down the different components that you necessarily or you will basically encounter when you're working with the CloudFormation script, whether it is written in YAML or whether it is written in JavaScript, it's the structure that is different, but focusing on the content is more important, is what you write in those scripts, right? So you can see here that there are probably like what, 1, 2, 3, 4, 5, 6, 7, 8, 9, and well, this is a single line. So this has about 10 different keys, right, for a given YAML script. So you can see that the dashes are here. It starts off here, right? So you have 10 different keys that is there. And then within that, you have some nested way of expressing what is that you want to kind of specify within these different keys, okay? So everything is optional except for the resources part. So to read between the lines, the resources is what will be executed by CloudFormation, and this is what actually will be physically deployed or provisioned to you. So be extra careful when working with the resources. The other stuff is mostly about, let's say, for if you take description and metadata, for example, this is kind of self-explanatory. We don't have to explain this much as to what could be there in description, what could be there in metadata, right? Parameters is if you want to provide some input parameters. Remember when we were launching our EC2 instances, there was a section or a field where you can specify user data, right? That will be executed once the software stack has been, or once the instance has been provisioned, right? So that is set of parameters. If you have any restrictions, you can do restrictions. Mapping is an example of this discussion that we were having, that if we have different subnets that would like to use different types of provisioning parameters, then you can create those mappings, because this is essentially a mapping. I'm taking subnet A, I'm doing something here. I'm taking subnet B, I'm doing something here. So all of those factors will go into mapping. If there are any conditions that is associated to your deployment, if you want to perform any sort of transformations, you can specify that. And if you want some kind of output in the form of performance metrics and stuff like that, then you can specify that within the output, right? So again, remember, you need to have a general idea of these being the actual keys that will be specified in any stack script for CloudFormation, okay? But the mandatory one amongst all of this is basically this resources, okay? And to a certain degree, you would also want to specify what template format version that you're using. And this is kind of available in the documentation if you're not aware of what you're working, okay? And this is the same example that we saw in the previous slides, which is kind of launching a particular instance type, okay? So moving forward, I'm not going to discuss the same thing again in JSON itself. Let us go ahead and start with our basic exercises. At this point onwards, you might want to set up your editor as well, because you will see these different scripts that are, at least I wrote it using Visual Studio Code for creating the YAML. That's basically the extension for YAML scripts. And if you're working with JSON, then you can use .json. Both the scripts, I believe, okay, both the scripts are not given, right? So you might have to convert this for those who are working with JSON itself, right? But work along with YAML, it's pretty easy to understand, all right? So we will move on to our AWS console, and we will start going through some of the basic stuff, and we will move on to a few self exercises for you to kind of test yourself out in CloudFormation and see what it can help you achieve. So, okay. All right. So this is just the AWS CloudFormation documentation that we were talking about. So you can kind of visit this documentation going to AWS and then going to the documentation and then CloudFormation. All of the things that we just discussed with respect to the different components of the template, if you want a deeper dive read on how this works, then essentially you can visit this template references, and then it will talk to you about all of these different properties that we talked about. What are the creation policies? What are the deletion policies? And those kind of different behaviors. If you want sample templates to start off with, and that is the best way to learn things like this. It's like nobody learns this from scratch. I mean, you can, but it will take a longer time. It's just easier for you to understand first the structure of what you're trying to write, and then find templates and then edit that template once you understand what that template is doing, and try to find something that is as close. So here we can see that there are some templates for our US East Ohio region, right? So you can visit the application framework. So these are all full stack. So we can see here that there is a basic LAMP stack that you can launch. There is a LAMP stack which has scalability and durability. There is an example for Ruby on the Rails application framework stack, and they offer you these 4 different stacks, right? If you want to go to different types of services, you can see that all of the things that we have discussed previously, right? In terms of, let's say, EC2, we have talked about DynamoDB, we have talked about auto scaling, we have talked about load balancing, IAM operations, relational database. So you can visit all of these individual operations. So you can essentially go to RDS here, and it gives you some sample stacks, and it explains you what these different database stacks are going to be. So if you want to learn more about it, this is the best place to start off with. The only difference that these things make is that if you take the sample and if you launch the stack, then it will be deployed in the region for which it is provisioned, right? So that is the main difference between these stacks. If you move to another different region and stuff like that, it might give you different types of examples, but you can check it out. I have not completely looked into that, right? But this is how you basically interact with it. And this is more fun. Now that you understand almost majority of the different infrastructure provisioning, learning this will be quite a good benefit to working with this. All right. So switching on to our actual AWS console, let us take it step by step. We can just take those stack and we can launch it, but we will do that later on in the exercises once we are more comfortable with working with the bare bone structure of these CloudFormation services. Okay, so from the search bar, I'm in Ohio, logged in as my IAM user profile. So we will look for CloudFormation. Okay, so visit the service. And this is what you will be working with. Again, as we discuss, every time we reach a new dashboard, if the widgets are confusing, ignore everything, pay attention to what is there on the left-hand side menu, right? So here, the first option is basically the stacks. That is the resources that you're going to be provisioning with CloudFormation. If you want to create a stack, you can just hit create stack. If you need help, if you need reference, then you go to the starting guide and it will take you back to the documentations that we were discussing here, okay? We can create different sets of stack, okay? And not just an individual stack. We can basically group all of these individual stacks that we want to provision into a single stack as well, right? So that allows us to create stack sets. And if you want to export any of these stack aspects outside and then store it in an S3 bucket, then it goes into exports. There is also an interesting thing that is here, which is known as the designer. Now, the designer is basically a canvas or a palette that is offered to you by AWS in order to draw out your stack and then let AWS generate the code for you, right? So this is pretty similar if you have taken a database course with me before. I introduced you to the SQL workbench, right? Wherein if you're trying to, let's say, design a particular database design, right? You can drag and drop from the different canvas options that you have, and then it can generate the data definition language SQL code for you, which you can then execute against the database itself. So the operation is pretty similar here as well. The designer option within CloudFormation, if you're not comfortable yet with writing the script from scratch, or maybe using a template and then modifying that and working with it, but you know what your architecture is going to look like, or maybe you are a visual learner and it is easier for you to kind of start off with some visual aids and then move into code, okay? Then essentially you would be coming to this particular canvas, okay? You'll be selecting the type of script language that you would like to work with. So you can either go to YAML and it will convert it to YAML. If you would like to work with JSON, you can work with JSON, right? To your left here, you have all the entirety of the resource type that you can find in AWS itself, right? So for example, let's say we come to EC2 here, okay? And then once we launch EC2, we can see that there is a lot of different options in terms of resources that you can launch for your EC2 options as well. So we will come here and we know that, okay, we need an instance here. So I will left click that, and then I will hold that left click, press hold left click, drag it, and then bring it here to this EC2 instances, right? And then if you want another EC2 instances, then you can keep on launching those EC2 instances. then you can click on any of these endpoints, and then you can connect these EC2 instances. We need a router, essentially, first of all, VPC router, because they don't communicate directly with each other. So we cannot set this up, but you get the idea. We can start dropping all of these internet gateways, and we can create our own VPC here as well. So let us just quickly check here, going down, if we can kind of work with VP3. So you can see that your S3 buckets are here. You can create a drag and drop a bucket here, and you can basically communicate with the bucket essentially through the help of an internet gateway. And then you can, let's see the VPC, don't see a VPC. There's a VPC lattice here itself. So, okay, so we don't have essentially the architecture itself, but there are different aspects of the VPC with respect to creating rules, with respect to creating listeners for any type of traffic, with respect to authentication policies and stuff like that. So you can bring all of these in together, and then you can essentially start working with this, right? If you do not want any of these existing policies or existing stack resources that you have brought in here, and you can see that every time we kind of create any of these policies, it creates these individual stack scripts for each of these policies, right? But once you start connecting them, it will start bringing them together with respect to how to kind of set up your entire ecosystem, all right? And if you want to delete it, all you need to do is just hit the delete key, and it will prompt us here whether we want to delete. And then, yes, we want to delete this, okay? So then you can kind of bring them together, right? Also notice there are information with respect to the different categories of keys that we talked about in our script, right? We talked about the properties, we talked about metadata, how the creation needs to take place, what will happen when a deletion takes place, is there any condition, is there any dependencies and stuff like that. So you can essentially kind of create those policies here. But once you start putting in the connections together with others different stacks, okay, it will start kind of populating all of those scripts for you as well, right? So you don't have to worry about that at the beginning if you are mostly comfortable with your operations, right? And this is the final template, kind of bringing all of those information together to kind of work or to kind of launch the stack that you're working with, right? So this is where you can draw all of your different stuff if you are not comfortable kind of working with stuff, right? And again, at the end of the day, once you have done everything, you can essentially download your architectural diagram, and it will kind of bring in all of the stuff that you have developed in the designer canvas, and it will you can save it in an S3 bucket and work with it later on, right? So this is a pretty important tool, and we will kind of come back to this to view all of our different complicated stacks here. So once we get to that exercise, we will work with that, right? So we will kind of stick to our basic stack right now, and then we will work with the first exercise, which is to write a very simple template, which was the EC2 instance template that we were working with, and then set this up, right? So we're going to hit create stack here, and then it's pretty straightforward. There isn't much that is going on. There are two different fields that you have to work with. First is creating your template, and the second one is then providing that template to CloudFormation so that it can execute it, right? So when you provide the template to CloudFormation, you have two options only. One, you can either upload it to an S3 bucket and then provide the URL of the bucket along with the object that is there in S3, which is basically going to be a script, or you can simply upload it from your local computer, right? So those are the two different options that you are working with. In terms of preparing your template, you can either say that your template is ready and then you upload it, or you can choose a sample template and then it will give you the different options that we just saw, right? So you can see here you have full stack applications, which are simple in nature, that it does not span across multiple subnets. If you want to work with more durable architecture, as we discussed in the database examples, then you have multi-availability zone deployments. And then you have different options with respect to Windows and stuff like that, right? And then if you want to, again, go back to your canvas, as we discussed, that designer canvas that we talked about here, then you can go there and you can create your canvas, all right? So for now, we will get our hands a little bit busy and we'll start typing things out and then upload it. So essentially, you can see that the script that we are going to write has been provided in slide 15 of lecture 11. So you can either copy it from there, But essentially what we are working with is this particular EC2 instance deployment. Okay, so you create a file with a .yml extension. You can give whatever name you would want to, but I would suggest that you choose something which is along the lines of identifying what exactly you're trying to provision, right? So here I'm trying to provision a very simple EC2 instance. That's it, nothing more than that, right? So I'm ignoring all of the keys that are optional within a particular YAML or JSON script. So we are just ignoring the template, we're ignoring the description, metadata, dependencies, nothing, right? So we're just focusing on how to launch a particular resource, right? So within the resource, there are a few things that you have to follow with respect to the template itself, right? Can you guys see this on my screen, or are you following the PPT? Is this readable?
It's a little small, but I can read it.
Okay. All right. If it's not visible, you can look at the snapshot as well on slide 15. Okay. So the first thing that you need, the main key is the resource again. Then for this particular case, since we're launching an instance, we give a key of what your instance is going to be, but then you simply just specify what are you going to launch, right? So in the instance, the first thing that you need to specify is what type of resource are you provisioning, okay? And this is where you first and foremost specify the type of instance, that type of resource that you're trying to provision. We saw that in the designer canvas on the left-hand side of the palette, there was numerous number of different AWS resources that was shown as an option, right? So here in the type of the script is where you need to specify what exactly are you trying to provision, okay? So we are going to specify AWS because it's a resource of AWS. Then we are going to take EC2, and within EC2, we are essentially provisioning an instance of the EC2, because if you go back here, and we need two of this so that I can show you side by side what I'm talking about. So if you go back here, essentially, if you go back to the designer tool, so you see the first thing that we say that, okay, AWS, so this is AWS, then we come to EC2. So let me reduce this a little bit. Then we need to kind of scroll down to, where is E? Okay, so EC2, and then in EC2, you can see here, there's a multitude of different EC2 services that is offered, right? So what the service that we want is essentially an instance. So this is what we are writing here, that the type that we want to kind of provision is an AWS resource, EC2, and instance. And then we need to specify the properties that instance will have, okay? So the first thing that we specify is the deployment region. If you choose to not specify this, this will be a little bit confusing for CloudFormation, but you can give it a try and see what happens just for the adventure's sake, right? But it's better to just specify the availability zone. So the availability zone, I'm specifying it in the exact format as it needs to be written, which is US-East-2A, okay? And then I need to give the image ID. Now you might wonder like, hey, how am I going to get this weird numerical image ID from? And as you guessed it, that is exactly how you are going to get it. You need to go to EC2 itself, and then you need to visit the marketplace, which is basically the AMI catalog. And then you need to check here that this is where the image instances are, right? So I'm not using the 2023 AMI. I'm using a little bit older than that, at least in the script itself, because we worked on it a year ago. So, but any type of different OS that you're using, you will essentially come to this AMI catalog from the EC2 dashboard, and you will kind of check out what is available, whichever one you want to use. And you can see that for each and every different instance, it kind of specifies the image serial ID for at least the x86 architecture or the ARM architecture, okay? So be aware of what type of architecture you are working with, and then kind of launch it accordingly, all right? So this is where you can get a list of all of these different instance types. You can even go to your community AMIs, and you can check out any kind of images that if kind of suits you from the community marketplace, and you can use those instances as well. So you don't have to generally stick with the ones that Amazon specifically provides, right? But for the sake of testing here in this particular instance, please make sure that you use the images that are free tier eligible only. Otherwise, you're going to pay for that, all right? So that is where I got this image ID from. And this instance type, you already know that you need to be kind of wouldn't say well versed, but at least be aware of what they stand for, what they mean before specifying them. If it is confusing, again, if you are not familiar with it, then just go to instance type here. And then it will start loading all of these different instance types, and you can check it out like, okay, I need something which is, let's say, has 8 different CPU cores. It's going to be general purpose. So just look for 8 here, and then kind of like work with what other aspects it gives, and then you can specify that particular instance type, right? So it's as straightforward as that. It requires some searching, it requires some understanding of what you're working with, but this is all that is required for us to kind of work with our YAML script, right? So save this somewhere and put it somewhere, and then all we now need to do is, once this is up and running, then we need to kind of upload this to our CloudFormation stack, right? So only thing, keep attention of the indentation that I have used here. Try to kind of stick with that indentation. There are 4 levels of indentation, excluding this particular child level here. It doesn't show the line here, but there is an indentation here of a single white space. So you have the root key here, which is a part of the actual template. Then within that, we are creating the resource, which is going to be an instance, specify the type, properties. These are at the same level of this particular parent. And then the final nested level for this child is basically, this is the parent for that, right? So for each of them, I personally used a single white space. If you're using tab, okay. But make sure the indentations are there, right? So please write this script, save it somewhere on your disk. And then all you need to do now is come back to AWS CloudFormation. We can close that canvas. You can say that template is ready, and then we are going to upload that from our particular file, from wherever our file is. So I'm going to go visit the location where my file is, and it is somewhere very complicated. Okay. All right, so I will upload my EC2 instance. If you want to view the same thing in Designer, then you can click View on Designer, and then this will kind of bring you with respect to wherever this is. So this kind of, I think I just saw it going down the screen somewhere. I don't know if somebody else also, oh, there we go. I'm minimizing it. That's why it's doing this weird behavior, right? So this is exactly what we did the other way around. Like we launched it from here, we dragged and dropped it from here. But this is essentially what we are getting here, okay? So another thing to note here is that once you do upload it, oh, it just vanished. That's not good. Come on, man. All right, so once you upload this file, just like any backup, it's going to store it in the S3 bucket. So it does not keep the file directly on CloudStack or something, or CloudFormation or anything. It cannot do that. So you upload that, it's going to create you a temporary URL for your S3 bucket. All right, and that's how you can view it as a designer. So once you're at this point, I'm hoping that everybody is at this point. Okay, then just click next. All right, you need to give it a stack name. So here I can say test stack EC2 instance. All right, we don't have any parameters, which is basically the input parameters that user are capable of providing when you're working with stacks like this. We don't have none of those in this particular example. So we'll just move forward. If you want to give some tags, you can give some tags. If you want to give any kind of IAM role to your instance that you are launching here, then you can essentially choose that IAM role, right? So we had created an IAM role. I think we deleted that. I don't remember exactly. But anytime for any resource, if you want to associate any form of IAM role to the resource that you're launching, then you can give it permissions here. Okay. In case your stack fails, okay, in case your provisioning goes bad, or if something faulty happens, all right, then you roll back all the resources. So this is similar to like a transaction from a database perspective, if you think about it, right? If you think about it, a transaction is composed of multiple queries, right? So if you create a transaction, it has, let's say, query 1, query 2, query 3, for example, right? So let's just push this up a little bit. So this is what a transaction is composed of, right? And we have this discussion in database transactions as well, that what happens, let's say if query 1 and query 2 gets executed, and then for some reason, whatever that reason might be, your transaction fails, okay? So what do? Do you preserve the state of your database with the intermediate queries that has been executed, or do you roll back the changes that these previous queries that were successfully executed were did to your database system, right? In database, the go-to option is to roll back, right? The go-to option is not to wait for the user, okay, to come back and resume this. Once it's gone, you need to restart, right? But here you get two of those options here, essentially, that you roll back all of the resources. So let's say before this EC2 instance, if I launch some S3 bucket and stuff like that, but then my EC2 instance failed, what do? Do I keep that S3 bucket or do I move on? So if you want to roll back everything, that is destroy everything, then you want to use the rollback option. If you want to preserve the state of the successfully deployed operations and you want to debug whatever failure happened, then you can preserve it, right? So that is up to you as an architect to decide how do you want to deal with this, right? There are some advanced options with respect to stack policies and stuff like that. So you can essentially write your own stack policies if you want to. If you want to kind of specify how the rollback is going to take place when a failure happens, then you can specify that as well. But this will require you to invoke CloudWatch. There is a separate cost for that. Then you can create an SNS topic, a simple notification topic. You can create that topic and you can associate that to your stack, that if something happens to your stack, then you will be notified depending on how you set up your notifications. And then if you want to try out some kind of timeout or something like that, where it is failing and you keep on trying again and again, then till what point do you want to keep on going, right? And then you also have the termination protection here as well, as you saw in database services. If you have the termination protection enabled, then you cannot delete this stack accidentally or intentionally, maliciously intentional behavior. But we are going to keep this as disabled because we want to kind of, once we're done with these exercises, we want to be able to kind of destroy these stacks, right? So go next from there. It will ask you for review of all of these different things that you worked on and then just hit submit, okay? So first of all, it will take you to events here. If you want the full information, like you launch an EC2 instance and you get all of those different features and parameters that are associated with the instance, such as DNS, public IP, and all those stuff, right? So if you want to get that overall information, then you go to Stack Info. Events is where you can see all of the log information that is taking place. So if you see some failure, or if you see some successful creation, or if you see some work in progress, then all of that information is basically tracked in event, because each of these it is treated as an event, right? The resources that are being launched, you can see them from this resources tab, or you can individually go to the respective dashboards as well, and you can check those things out as well, right? If your stack is supposed to provide you with any kind of input, you can see output, it will be showing here. Parameters, the same goes. If you're providing it, the template that you have used, the script that you have uploaded, you can see the source code of that script here in the template section. And then if you want to change any kind of different behaviors for existing stacks, then you can provide those chain sets here, right? So you can create a chain set, you can apply that, and it will apply it to the existing stack that you have worked with, okay? So we can see here from our log file, or as they call it, events, that essentially our stack is essentially complete. And remember that we had launched this in 2A, I think, for Ohio. So if we go to instance at this point of time, and if we go to instances, then we can individually see by visiting the individual dashboards of the resources that CloudFormation is creating for us, right? So it is pretty slick when it comes to working with CloudFormation, and that's the reason why I kind of like this, right? So if you want to update the stack, you can hit update here. If you want to delete or deprovision the stack, then you hit delete here. So anything that is specified in the template itself, which resulted in a provisioning, remember that can be deprovisioned when you hit delete. But if there is any information that you added, any data, any resource that you added after the stack was created using the script, and then you hit delete here, then note the changes that you made outside of the script, CloudFormation will not be rolled back, will not be able to roll back those changes. So this is a major thing that you need to remember. Sometimes you might think that, oh, let me just delete the stack, delete all the resources. No, it will not, at least those ones which you added after or outside of the script. So be careful about that, right? You can go for essential options here, but these are more advanced options. So for now, you should focus mostly on how to get a stack running and stuff like that. So any questions? Is this understood? It's pretty straightforward how to work with this. But is the process clear? The generic process of how you work with a bare bone stack environment? Yes? Yes, no, kind of. Okay. So the next exercise that we're going to be working with is essentially to implement this mapping scenario that we talked about. Where is the mapping scenario? Here, this type of mapping scenario, right? Where let's say in different region, in different subnets, you have different mapping of, let's say, different instances. So how do you specify that? Well, we saw in the general structure of the templates that we were discussing that there is a key that is known as mappings itself, right? So we are going to now add on to the resources key that we just looked into in the first script, and we're going to add some more parameters to it from the mapping, with the objective of what we want to do is that we will take different regions subnets. Okay, we'll take subnets from different region. You can keep this thing running. It's okay. It's not going to take up too much cost there. We have a lot of free tier usage, so we will use that. And then we are going to take different mapping for different regions, different subnets, and we're going to specify different guest OS distribution for the EC2 instances that we are going to launch. And we are going to kind of isolate them based on whether we are in a development environment or whether we are using a production environment, right? And based on that, things can be changed. All right. So moving back to our script here. So this script is basically titled as EC2 instance mapping. Okay, so we're just going to build upon simple stuff and create something that is much more, I wouldn't say complicated, but better than the most simplest option, right? So here, let's deal with the resources first. The resources is exactly how we work with here in the EC2 instances. So we need all of these different parameters again, but we need to have a set from which we can specify which OS distribution to use depending on the region subnet and depending on whether we are working in a development environment or whether we are working in a production environment. So that set creation, that creation of, let's say you can call it an array, basically we are going to specify that within another key of our stack script that is known as mapping, right? So let us look at first the one area or the key that we already discussed in the previous exercise. So the instance is being created. The type is AWS EC2 instance. That is the same. No changes here, but things start to change with the properties itself. Okay. And the way the thing starts to change within the properties is that the image ID, we are not going to statically code that. Like we did here in the image ID, we specified an AMI Linux, Amazon Linux distribution, right? So we cannot hard code that because we have an if-else condition. And the if-else condition is kind of governed by what region we are in and whether we are in a development environment within that region or whether we are in a production environment within that region, right? So there are kind of like two conditional statements that we have to figure out with respect to what image ID to use and then what instance type to use as well. Depending on what we are working with, we will change that. So maybe in development, you can go with a smaller spec. In a production environment, you want to kind of start with a larger spec compared to the development, right? So we're going to leave this empty. We're going to revisit what all of these means, okay? So in order to create these sets, we're going to move first into the mapping key, okay? In the mapping key, we are going to set up an instance mapping, okay? You can map different resources. The resource that we are mapping here is basically an instance, all right? So that is why we are setting up a key for an instance map. And the value that it has is basically a nested pair here, which says the instance mapping will have two different regions. Okay, so first of all, it will be deployed to US East 1, okay, and then US West 1. Can somebody tell me what is US East 1 and US West 1? Real quick. Any ideas? Just as a test. where are we right now? What is Ohio known as? So Ohio is US East 2. And when you get this A, B, and C notations, that implies the availability zones within a particular region. Okay, so the number is the region, and then depending on the country, and then east or west, etc., that is basically the geographical mapping. And the letter is the availability zone within that particular region. All right. So if you want to leave the availability zone out of the picture, then you just leave it to the number. So here, basically what we are saying is US East 1 is Virginia. Okay. And then US West 1, I believe it's either Oregon or California. I'm not sure from the top of the head, but it's one of those two regions, whichever one it is. Okay. But this is implying an entire region and no specification with respect to the subnet. Whereas what we did here was region and subnet specification together. All right. So here, if I change this to US East 1C or 1B, something like this, right? Then that would be region and subnet specification together. Then we say we create two different keys. Okay. One we call dev to identify development. Then we have prod for production. So what we're saying is when we are in the development environment, use T2 micro. When we are in the production environment, use m1.small. Okay, so we are creating the mappings for now. Okay, and then we will change the mappings later on. We will just specify these keys and it will grab them. That is essentially how we are setting up that particular map, right? So similarly, in US West 1, we are saying T2 micro, but instead of using M1 small in the production environment, use M1 large, right? And then we are creating another key, okay, after the instance mapping is done. That is where the region and what type of instances that we are going to be using. Then we need to specify essentially the OS distribution that will be used within the development and production environment. So we go and take up some different type of environment or AMI images, right? This image instance itself, the serial ID doesn't matter more than the fact of you understanding that you can specify different image ID by using this type of map. Okay, so we set up an AIM map, then we choose the different regions that we already specified in the instance map, because if this is different, then it kind of, you know, puts a wrench in your whole process. Take dev and prod again, the same structure, specify different AMI instances or AMI images that you want to specify. Now, once that is set up, what we are left with is basically two different keys. One is what type of instance you want to use, depending on the regions, and then what AMI images to use, depending on those particular regions, and given if it is a production environment or a development environment. So what you do is you use this syntax, and this is a direct syntax coming from the template for stack formation itself. You use this not find in map, and you call the key, which is AMI map itself, because this is going to be for your image ID. All right. And then you're going to refer to the AWS region and specify whether you are working with the development region or whether you're working with the production environment, right? So this is where we are specifying. So if I change this to prod, if I update my stack, we saw here that if you look at it, you have some options to update your stack itself, right? So later on, if I come back and change this dev to prod, then essentially it will just redo the scripts and it will kill the instances that was already being provisioned, and it will relaunch the new instances based on this mapping that we specified here, right? So the new thing that we saw here, or that we just learned here, is this directive here, which is the exclamation find in map, and then you provide the key for which you're basically generating the value, right? So we are generating image ID here. So I will provide AMI map here. And then the next is basically the instance type. So here I will specify the instance map, okay? And then it will refer to the region and then the environment. So three things that we're providing is where is the value information, what it is referring to, that is basically which region. There are two regions that we have specified here. And then within that region, if that is going to work with a development environment or a production. Okay, so is this clear? If everybody is ready, if you have written the script out, then you can simply just do the same process. Is you can copy all of this, not copy, sorry, save it as a .yml file, and then just upload it to your stack there, right? So let us go ahead and do this process as well. Any questions?
Yeah, can you go back to that script? Yeah, here this instance map and AMI map, these are the keywords, right?
Yeah, so we have created keys here.
So they are standard keywords for this?
Mhm.
Okay, okay, fine.
Okay. So what we can do is we can kill the previous stack, or you can let it run. Doesn't matter. If you want to create a new stack altogether again, then we can use the new stack here, existing resources. If at any point of time, you kind of go back here to all of this and you visit your stacks here, okay? So you can either create it from here, or you can go back to your CloudFormation and you can create stack from the dashboard itself, all right? So again, for us, template is ready because we're just getting a hang of how to write up all of these things. We're going to click upload a template file that we just created. And then I'm going to choose the file, which is instance mapping, okay? So it will create this instance mapping. This time, maybe I'm just not going to do the same mistake, and I'm going to middle click it. So it comes here and launches it somewhere weird. So I don't even see it. So we have to find it somewhere. This time I didn't pay it. Here, there it is. Okay, so we need to kind of move with this guy. It's a single instance at the end of the day, depending on where you're launching it, because we did not specify multiple instances at the start. So here, one more thing to note here is that you can attach all of these different volumes and stuff like that. So if you visit all of these different endpoints that it has been created for your instances, it will show you those different properties of what you can put there, right? So if you're trying to connect some other behaviors to this particular instance, you can see what can you actually do with it, okay? So those are some of the options. So I'm going to delete this now. And do I still lose it? No, I don't. All right. So we're going to go next. And we're going to say here test stack, give it some name. And I will just say instance mapping practice. All right. Go next. Keep everything default. I'm not going to open these menus up. Check everything. Looks good. And just hit submit. Okay, I think we missed something, did we? Did I miss something? Oh, parameters have changed here. So we need to get the new AMI map for US East 2 dev. So we are in Ohio, and this is where the problem lies, if you guys have already realized it. So we are getting a error with respect to the fact that it cannot get the mapping for US East 2 dev, right? The problem is we are in a different region and we are trying to launch an AMI mapping that we have written for a different region altogether. So if you notice here, the regions that we are working with is basically US East 1 or US East 2, okay? So what we are saying here is we are taking the development environment and refer to the region that we are in. So when this AWS : region gets executed, this is what it grabs. So when it grabs this, it essentially grabs US East 2. So the script then replaces this particular value with US East 2. So when it goes to this US East 2, it goes looking for these US East 2 here, but it finds nothing here. Okay, so as a result of that, this is where the error that we have received, all right? So if you want to correct this error, I hope you know what to do. Anybody would like to tell me how we can resolve these errors? There are two ways we can work it out. What are the two things that we want to do, or the two ways that we can resolve this error? First of all, is the error clear? That's the first question. Do you understand? Yes, no, thumbs up, thumbs down, anything will help.
I'm a little confused.
Okay. So here, you can see here, when we wrote the script, as you can see it on my screen, we are referring, so this is what the syntax is doing. It is telling AWS when we execute this particular script to refer to the current AWS region, and the script is supporting that AWS region, and then go look for the dev key, the development key, right? So when we upload, is this part clear? Just this much. That we are telling AWS to grab the current region that we are in.
Yes, sir, that's clear.
Yeah. So when we go here, what is the current region we were in? Ohio, right?
Right.
Ohio's code is US East 2. So if now I replace this with US East 2, that means, and I start go looking for dev environment for my image ID in this key, which is AMI map, do you see any US East 2 here?
No.
No, right? And that is where we get the error from, because you can see here, it is looking for AMI map key, US East 2 dev. But if you notice the script that we wrote here, for AMI map key, we either have US East 1 or a support for US West 1. So it cannot essentially find that, and that is where we get the error from. So how do we resolve this? There are two quick fixes for this.
Can we just type in US East 2?
Yep, that's the most straightforward fix. You can either change this to US East 2, or you can add a US East 2 here right after this particular key. You are not restricted to having just two nested key values here. Or if you still want to work with the same file without editing it, another alternative fix would be to just move from Ohio to the one which says US East 1, such that when this script gets executed and it goes referring to the current AWS region that you are logged into, then it will be able to find it. All right. So what we are going to do, either one, you can try it out. I will let you guys work this out. All right. So this is going to launch a development environment instance within US East 1. So you will get only one instance, by the way, just to be sure. But anytime you change any of these script values, then it will basically kind of grab whatever mappings that you have specified and it will launch it. So this makes it more automated, right? You don't have to manually go and change it. All right. So can I get a vote of whether everybody understands the bug, and can everybody clear that bug out?
Yes, sir.
Okay. For those at least who are working hands-on. Is it clear? Is anybody still confused? Any doubts? Any questions? Can I leave this as an exercise that you can do? Or do I need to show you the bug clearance? No, no interaction? Today is not the day. Okay, so we need to back up here, go back to the previous screens. All right, and what we can do is we can just change this, but this will essentially change the whole thing as well. So we are not going to mess with the region itself. So if you don't want to mess with the region, then essentially you need to change this US East 1 to US East 2. And if anytime you're in US West 1 and you launch this, then and you specify, let's say, dev or production, then based on the mapping that you have specified here, it will essentially execute it, right? So please finish this. And I am pretty sure that you will be able to do it, at least for those who are trying now, those who will try later, all right? All right, so the next exercise that we want to do is basically with respect to parameters, all right? So now that we learned the different types of resources that we can launch, not different types, but how to launch a very simple resource, and then how to perform, let's say, things like mapping. The next thing is we will look into another different main key of a script file that is known as parameters. Okay, so parameters essentially will allow us to kind of automate the process of specifying what type of instances to include with our operations. All right, so what I mean by that here, if you saw the previous example or the previous exercise that we worked with, you can see here we said that in dev environment we are using a T2 micro. In production environment for this particular region we are using an M1 small, and then in a production environment for US West 1 we would like to use an M1 large, right? So if you summarize this whole operation, we can kind of tell ourselves that there are three different types of instance types that we are essentially entertaining in this particular example, right? So that means we are using a T2 micro or an M1 small or an M1 large, right? So what if you have something of a similar situation where there are different options for you to choose from, and depending on the scenario, you would like to pick from one of those options, right? Or you can allow CloudFormation to essentially pick from any one of these options, depending on how you write the logic of your script, because you're essentially kind of entering into the realm of I wouldn't say programming, but essentially scripting that you're working with, right? So this is the next exercise, and this is what it deals with, is that if you want to automate the process of the parameters that you specify as values for different key instances, then how do you automate that process as well, such that you don't have to individually write everything out, right? So that is this exercise, which is the parameter mapping, right? So here, what you can do is you can take instance mappings as well. You can keep it if you would like to do that exercise by yourself so that you build on top of one another. But we are going to kind of focus, at least for this sample that I'm discussing, on the parameters as well. Okay, so specifically on the parameters. So again, the main thing that is resources is there. We have our instance. We specify that our instance is going to be an EC2 and an instance type. Properties, availability zone. So here, we are specifying specifically that I'm going to be deploying it in US East 2A, and we won't get an error this time. I always fall for that for some reason. So I need to fix it tonight. So I specified here. So what you guys can do is you guys can keep your instance mapping, and you can continue with this operation here, and you can use these different properties that we're working with. But I fixed the image ID, and the instance type, instead of specifying it as T2 micro. So here you can see that there was an instance type, and I hard-coded that to T2 micro, right? So in the second exercise, we saw how can we automate the availability zone and the image ID itself by doing mappings, okay, or parameter mappings of those different factors, right? In parameters, we can essentially automate the process of what needs to be spelled out, all those different options, all those different parameters. So here, one of the parameters that we can use is how we specify instance type, right? So we are going to be using a keyword that is known as ref. Okay, this is a syntactical aspect, so you have to use it as such. And then we are calling on the key that is specified as a value to the parameter's root key. Okay, so the parameter itself is a part of the main structure of the script documentation. So we are setting up a key value. I name this value here, and then I specify the same name here whenever I need to refer to it. So this is acting kind of like I wouldn't say a function call, but that's the nearest example that I would like to give, right? So we don't want to invoke pointers here, but just think of it as a function call, so to speak, right? So when this is essentially called, this will replace it with the value, all right? So within the parameter mapping, I need to specify the data type that I'm working with. So I'm working with the string type here. The default value I specify as T2 micro, okay? But the allowed values that I specify here is T2 micro, M1 small, and M1 large, which essentially were the three different types of instances that we were working with, right? So essentially what you can do is if you combine this particular exercise, right, where you have a mapping of your instance type and your instance ID, with this particular example where you're kind of changing around the not having to type out the different set of instances which are allowed, right? Then you can essentially put, instead of saying T2 micro, all of these things here, you can do a reference here that you have done in this particular scenario to the key itself, and then it will pick it up from here, depending on whether you're working with a development environment or whether you're working with a production environment, right? So this allows you to kind of specify all of the different allow values, all of the values that it can take, okay, depending on the conditions, or if you don't specify any conditions, it will take the default value generally for a particular key pair, okay? So you can, and the final thing is you can give it a description here, all right? So the description is depending on what you are working with. It's kind of good to have with respect to the documentation, all right? So if we upload this now, we can kind of check and see what is going to happen. So I just want to make sure that we are in US 2A. That's the only thing. And then we are going to hit for creating a stack here, right? So we're going to create a stack. Template is ready. We want to upload a file. We want to choose from the files, okay? And then we're going to choose the parameters here, all right? Then go in next, okay? And we can say test stack for parameters, parameter mapping. All right, so notice here, the moment we do the parameter mapping, it understands that we have a set of options that we can choose from. So previously we didn't have any kind of user parameters. We didn't specify what parameters are we going to use. So it just picked the one that we hard coded because that is what we specified for the image ID, right? But here, when we go to the instance type, we can see that it is referring to a key which has a default value, and it understands these values because we have said that the data type, what you're reading, is in string format, okay? So, and then we are creating an array. Remember in YAML, if we have these single dashes indented after the key, this is basically creating an array. So in JSON, this will look as an array, specifically wrapped in a third bracket, okay? And in the array, we are providing the values, the allowed values. So once you upload this script, the major change that you need to notice here, that the parameter section is now populated by the values that you have provided to it, and then you can pick from those different values, right? So for free tier purposes, I'm going to stick with T2 micro, but notice how it gives you all those different. So the more parameters you write, you will see more different types of stuff that is coming up here, right? Where you can choose from. So go next. No IAM role, keep everything kind of as is. So this will allow me to review it again. Okay, so here I have already selected parameter T2 micro. We don't have any other different types, and then we will just submit it, and then it will just create the parameter, okay, in US East 2A. So that's how you can automate the process of selecting from a multitude of options that could be applicable for a given type of property that is associated to a feature that you're trying to launch, okay? So this will happen as we saw for the previous one with a little bit of exception. So we will look into the last one, which is essentially a little bit different in order to kind of emphasize on the fact that any resource that is not created by CloudFormation cannot be deleted by CloudFormation. This is a pretty important concept that you need to know. And this is what exercise 5 on your slides essentially kind of emphasizes on. So what you can do is notice the fact that what we are doing is a little bit different from what we have already worked on, right? So the resources I'm deploying, I'm creating some sort of key, whatever key that you want to create here, you can create that key. But the type that I'm creating is now, instead of an EC2 instance, I'm creating an S3 bucket, right? I'm going to launch it, right? And I'm going to change the access control to public read. So that will allow basically universal access to any content that will be present in this particular bucket. If you're again not familiar with, oh, how should I specify the access control policies? Well, the easiest way to learn about that is to go to the S3 dashboard, create an S3 bucket, and then it will walk you through in a UI interface, the different policies that you can create, right? So that is how I got the public read from, by unchecking the box that allows for universal access throughout all of this stuff, right? And then I want to turn this S3 bucket into a static website hosting container, right? So I'm giving it some website configurations, and I'm specifying what is going to be my index document and what is going to be my error document. So just by these few lines of code and nothing else, I can just create a static website container from my S3 bucket without even having to touch my UI, even the slightest, right? All you need is this 8 lines of code. And that is the beauty of CloudFormation that you are providing, right? However, please note, you are specifying file names here. Like you did for the previous exercises, whenever you are specifying a key, the value was already available in the script itself. So it was able to populate that on the UI when you're creating that, or if it's just a mapping, then it can grab all of those different stuff. It can do that for you. But an index.html file and an error.html file is not a part of AWS. It is a subjective file content, right? So that means once this bucket has been created, before it is fully functional, you have to find that S3 bucket and you have to write an index.html file or an error.html file with the same name as you specify here. And you have to drop that in your S3. You have to drop that, okay? So once you delete this particular provisioning aspect, what you will notice is that the S3 cannot be deleted. That means the bucket that you will create, please try this exercise by yourself. This is a way to understand the important thing, that anything that CloudFormation doesn't create, it cannot delete. And here in this situation, the objective of the exercise is to automate the process of the creation of an S3 bucket and convert that into a static website hosting container. All right. The only two things that we need to manually provide is an index.html file and create another file that is known as an error.html file. And we need to upload these two files manually to the S3 bucket that will be created by this particular stack. Okay. The main objective of this exercise, not just is to learn this static website container creation through CloudFormation, but it's also to understand that anything that CloudFormation doesn't create, it will not be able to destroy. So what is essentially going to happen when you try this script out, when you upload this script and execute this in CloudFormation, when you try to delete this script, that is when you will see the problem, is it will tell you in this event section here, where it is giving all of these different messages, that it cannot delete S3. And the reason why it will tell you that, and I will tell that ahead of time, is that you guys will be writing your own HTML and your error.html file, and you need to upload that separately to the S3 bucket. And that is something that CloudFormation was not in charge of. So since it was not in charge of uploading those files, it cannot essentially roll back the S3 anymore, because there are two files that is present in S3. Remember, you cannot delete an S3 bucket unless it is empty, right? So it struggles with the fact that it's trying to delete S3 because it provisioned S3, yes, but now there are two files within that which it did not provision, it did not upload, right? So you need to manually delete that, at least for this particular case, such that then you can roll it back. Is that clear? Is the objective clear? Yeah. So try it out. You will understand and be able to appreciate the only thing that you need to be aware of in terms of deprovisioning. All right. So I'm going to leave this to you. It's pretty straightforward here. And then the last thing that we want to talk about is, maybe you can come to these once you're done with all of these stuff and you would like to try out new stuff and things like that. You can start with application frameworks, because that's one of the easiest way to kind of work with it. Don't hit launch tag, because it will just execute like a bunch of different stuff. So as long as you are, I think, signed into your container, and I don't know why it keeps on doing this. Okay. So it will start creating all of these different stacks, right? And you can check that out in your designer canvas, and you can interact. This is kind of okay. So here, this is with all the connectivities. So this, what we are looking at is a fully functional LAMP stack, which is basically a full stack web application that is supported by a database, MySQL database, RDS database that is there. It is also supported by an application load balancer, okay, which is running in front of our application itself. And then we have a target group. A target group is necessary to run an application load balancer itself. Then you have a web server that is governed by an ASG, an auto scaling group. And then it has a security group that is essentially governing our web service itself and how the communication is going to be launching. And this is the configuration file for our auto scaling group. So it is kind of connected to this particular location. So this might seem a lot, but it is not. These are all the exercises that we have done to this point. Okay. So essentially, the next steps for you to get a little bit more comfortable with respect to CloudFormation is working with these samples, starting it up, looking at the architectural diagram to understand whether you can reason with it, right? So what will happen if you have a LAMP stack? Now, in a LAMP stack, you need to add auto scaling group. In an auto scaling group, if you want to add a load balancer, how would it look like, right? These are all the things that we have already discussed, right? But individually in components, and we have brought them together now. Now we are looking into how to automate the process of those creations, right? So once you look at this architecture, understand the connectivities, the next step is to then move into our script side. And then you need to pay attention to the root key values. So for example, you have, well, you can ignore this part here. You can ignore this part here, but start paying attention to the parameters. So we discussed one exercise about the parameters here. And this is creating different set of parameters, right? With respect to a VPC, it is launching a VPC, it is specifying what VPC that we are using, right? In terms of subnets, in terms of the key names, okay, that we are going to be using for authenticating ourselves to kind of get into those different servers that are being launched, in terms of the database and all the parameters of the database that we need, that needs to be specified as parameters itself, our database users, in terms of authentication, the password. So all of these different values, and then the allowed value we can see here is with respect to the database compute engine for the database server that will be launched. Then we have a parameter mapping for multiple availability zone deployment. We saw this exercise happening in relational database itself. So it specifies whether it can or cannot do and stuff like that. If you keep moving forward, there's a lot of parameter mapping that is going on. Then we have the next segment of our script, which is the mapping key. We already saw that in the third exercise. So now it is just doing the same thing. It is just specifying that what type of architecture to use and what instance type to use for all of these different mapping. And it does a very comprehensive mapping. So you get the idea of what it is doing, right? So once you look into all of these, we go through the image instance process, application load balancer. You need to come down to resources somewhere. And here you can see that in the last exercise, the one that we discussed, I asked you to create separate HTML files and upload it by yourself. And this is where CloudFormation doesn't have control over the HTML file. There is a process to give CloudFormation a control over the file itself. And this is where you see that they are writing the HTML script within CloudFormation. So now the file that will be dropped, so this one is going to be an index.php file because it's a LAMP stack, okay? It's not a straightforward HTML. So essentially index.php will become the landing page. So if you write the file, if you create the file, specify the folder where you need to drop it, and then you write the file here itself, then as long as you have given CloudStack the control over the creation of every resources, if you deprovision it, it will be able to roll it back, right? But however, if let's say, for example, you had ignored this step here where you are creating the index.php file, which will eventually be dropped into this particular, not web security group, but wherever this EC2 instance is running within the ASG, this auto scaling group, which controls all the EC2 instances, right? So it will drop it in the CD www var HTML folder, right? So essentially, if you do that separately, that is once the instance has been created, you upload that file there, then EC2 CloudFormation will start behaving a little bit weird if you try to deprovision everything using it, because it won't be able to roll back things that it doesn't have control over, right? So this is basically the next step for you to test it out. And then finally, you need to kind of get more, this is how you can get more accustomed working with automation using CloudFormation for different types of resources, right? So there is an amplitude of different examples here in the stack formation. We talked about the 3 major different keys to wrap up this lesson in this particular lesson. The first one is the resources key, which specifies the actual resources. Then how to do different mappings, and then call those mappings from our resources, and then how to provide user input parameters when you are working with a set of allowed values, right? So you can get more examples of that from the documentation itself. So in the next class, we will discuss about Elastic Beanstalk, which makes the process of designing web applications a little bit more efficient, right? So I will see you again on Wednesday.